Hello everyone, November the 4th. Alright, let's go for it. Find the winner of an array game. Give an integer array of distinct integers and integer k. A game will be played between the first two elements of the array. In each round of the game, we compare array 0 and array 1. The larger integer wins and remains at position 0, and the smaller integer moves to the end of the array. The game ends when an integer wins k consecutive rounds. Return the integer which will win the game. It's guaranteed that there will be a winner. So we start with 2 will win 1. So basically you set a winner, right? And so the winner will always be at this position, and you have a pointer goes into this and this. Compare. Whoever is bigger, move on this, and you move forward, right? Compare. Move here, you move forward. Compare. Move here, move forward. Move forward. So this one goes 5, right? 5 because 5. Okay, 2, 1, right? And then 2 wins. You move this one forward. And then 3 wins. Move this one forward. 5 wins is 1. 5 wins again. Okay. I think you just follow whatever it's said in the description. Well, good news. Before I start doing it, look at that. No, this one. Wait, hold on. No, not these. Look at that. We resolved the issue. I'll talk more about this later, but I haven't read discussion yet, so this is definitely not good, right? It's a pretty bad solution. So we'll see how the good ones are, but we figure it out. I figure it out like after yesterday, very frustrating, and then I end it, and then I go back to the problem, look at it. There's some issues, something wrong, you tried a bunch of stuff, and then yeah, eventually it just started working. I'm very happy that it starts working. All right, so this one, so we're just gonna have 2 integers. Int I is equal to 1, okay? And we have to say int wins. Int wins equal to 0. So while win is smaller than k, right? Because it has k consecutive wins. So while w is smaller than k, we're going to compare if array 0 is larger than, I say the larger one wins, right? What if they're the same? The smaller ones move to the end of the array. Oh, what if I wrap around? If you wrap around, which is fine, you just, when you wrap, you always wrap to the first index, wrap to 1. You never wrap around to 0. But is that right? Is that right? Maybe it'll be better that you use a different data structure. I was thinking maybe I can do the index, but then I realized I was thinking about swap, but swap is not really right, because the other one, the smaller, has to move to the end. So no, that is not it. So we're just going to use a queue, right? Q equal to new. Nope. What do I do? There's no Q, right? A deck. We have a deck. Wait, no, there's no deck. Wait, there's no queue? What's the queue? Java queue. Priority queue, linked list. So I can use a linked list. But I remember there's a deck. Oh, I think you have to do deck here too. Array deck. Right? Yes. Yes. I think it's array deck. And what we do is just push everything into the array deck. So for int I equal to 0, no, 1. Right? So we're isolating it. Right? We're isolating it. We're saying int the winner is equal to. Do you want to do the first round or do you now want to do the first round? Yeah, I think we should do the first round. Right? We should do the first round. So that should be mass dot maximum array 0 and array 1. And for int I is equal to 2 smaller than array dot length I plus plus, we say q dot. Oh shoot, I see. K can be huge. Ah, you're gonna time out if we do this way. Okay. Okay. Ah, gotta think about it. Plus, it's not that easy. Yeah, I see the trick. I see the gotcha thing. I see it. Yeah, you have to go around and around and around and around. So we cannot do that. Cannot do that. So we can at least go through the first round. We have to check every single value, right? And if you check every single value, you can use a deck. Yeah, I can definitely see that. So once you go through, how many rounds do you need to go through to know which one is likely to win? So as you go through, right, eventually the largest value will go to the front. That makes sense, right? So we just go through and eventually the biggest value will go to the front. Right? The biggest value will go to the front. If it's equal, it just doesn't matter. So when we go through, the biggest value will go to the front. Yeah, we do it, once, twice. How many times do we do it? Basically, that's already one. Compare one comparison, right? 2 comparison, 3, 4, 5, 6. So it's n-1 comparison. So we go n-1 times, and after we do n-1 times, the biggest will be at the front, and then you can mod, right? Then you can mod. Actually, you don't even need to mod. You don't even need to just go through that, right? You go through the entire array length. Then if the k is larger than, then just return that value, because it will always be that value. So it depends on the k value, right? It depends on the k. If k is larger than the size, or it's larger or equal to the size, then it has to be the largest value. K consecutive wins. Yeah, if K is larger than the length minus 1, then the only possible value to do that is the largest value. Right? The only possible is the largest value. So we can do that and then just find the largest value and then return it. If it's smaller, then we have to do this. Okay, that's my new idea. Okay, that's my new idea. But this is also a when, so I guess, no, just a few more. I don't know, what do you think? I think we can say if K is larger or equal to array.length minus 1, then we can say must return the max of array. Then we say int res equal to 0. For int a of a array, res equal to math.max res in a, and then return res. That's what I think. Otherwise, we do a deck, get a winner first, get a res, put in the deck, push. Right, we're gonna push array I, push it in, and then q dot push one more is math.minimum array 0 array 1, and then int win consecutive win is equal to 1 because the first one wins one time. And then we say for int I is equal to 1, I is smaller or equal to, we'll go how many times? Array.length minus 1. Actually minus 2 because I already done one time. We just go through the entire thing, right? So we've done 1, and how many? We have n minus n minus 1, right? I've done 1, so I have n minus 2 left to go through. All right, I plus plus. Then we just follow, right? We say pop, right, and current. Or maybe, you know what? We take the winner out. Yeah, we take the winner out. That doesn't matter. I can just choose array 0. Take the winner, potential winner out. Okay? Take the potential winner out. I go from 1 to the end. I don't do this. We have the winner. Consecutive wins currently is 0. And we say current is equal to q dot poll. And not q that is empty. Right, so poll 1. Oh no, we have to push at the end. Oh, we don't have to. We don't have to. We just poll. Yeah, we don't go through. That is wad. Then we don't even need a queue, a deck. We don't even need a deck. I think a stack will work. You just put everything. Oh, dude, stack doesn't work. Has to be a queue. No, you don't need anything. You just go through. Yeah, you don't even need this. And what's the point? All right, what's the point? You don't need this. You don't need this horse. Just go from the 1 and then just keep going. Yeah, this is a. I think this will be fine, right? So current, I can just say array 1, array I, right? So I don't even need current. This is not necessary. So what I do is check array I. The winner is always going to be 0, so this is not even necessary. So I just check this, right? If this is larger, then we set and we say consecutive win plus equal to 1. And next, yeah, if this is larger, oh, you do kind of have to check the first one, because if it's array 0 is bigger, then we just increment. If array 1 is bigger, then have to reset, right? Have to reset. But at the beginning, we don't know. So I do have to. Okay, unfortunately, array 0 has to equal to math.maximum array 0 and array 1. I have to do that. And consecutive win, I have to set it to 1 consecutive win, and then we set array 0. So that's 1 win already. And then we're gonna go start from 2, right? Because 0, 1 and done, so it's from 2. So we say if this is larger than array 0, right? Then what we do is array 0 will be equal to array I, and consecutive win will equal to 1, reset. Else, consecutive win will be plus plus. So you just keep going, right? And then we also say and consecutive win is smaller than k. So when our consecutive win becomes k, we'll pop out and then return array 0. And of course, once this all go out, once we hit to the end of this, so we go through everything and then we still haven't reached then the maximum, so we don't even need this. This will handle both situations. Okay. Give it a shot. It's working. Yeah. You wanna let's take a look. There we go. There we go. Yeah. So there's a little bit trick there, right? There's a little bit trick. What's the crack? What's the crack? What's the crack, horse? Yeah, it's for the horse. Horse. All right. So since k, right? Since k can get really big, it is not possible to simulate the entire process. We recognize that after going through the array for the first time, the largest value must be at array 0 and its position, and it will never be dethroned again. This means if after going through the array and k is still not matched, then whatever value at array 0 must be the answer, since it will win forever. Thus, we only need to consider one pass of array. and since we don't need to worry about moving the elements around, a simple iteration would work, and that'll be OM. Horse. It's pretty hoarse. What's the crack horse? Alright, what's the solution horse? Simulate with a Q. What is it? Return -1. Oh, really? Elements in the array are unique. I didn't know that. Thirsty. I feel thirsty. That thing over there. Over there. Yeah, that's true. Yeah. No matter how large the required K is. Yeah, that's true. It will be current, it will be winning. No Q. Yeah, I definitely can do it without Q. Yep, this is the one. All right, pretty good. So let me go back to discuss this thing. Man, this thing is a massive overtaking. I'm not gonna deal. I want to take a break from this problem for a few days before going to the discussion. So basically, we had wrong answers. Right? Yesterday I have 2 wrong answers, and thank you. I feel grand. Remember that they say, how you feeling? I feel grand. Now I just want to use the phrase. What's the crack horse? I'm up to 90, working on LeetCode. All right, so this one, yeah, we have a couple of errors, small errors that I didn't notice. There's one, Lord, I don't even know where. Here, somewhere here. Yeah, that I didn't do this. And now no, not this one. This one. I forgot to minus this, so that's kind of error. So we got a couple of errors. So this error was because of what? This error is because of that. Because here, right? So I have a preds, and you're supposed to minus preds here, but I forgot to minus preds here as well. So they both has to minus. So that's the reason why this is wrong. And this error, this minus, right? What I realize is, if you do this mod, add this value, you get this value, which means at the end we shouldn't return just int this count, because this count can be negative because of no previous. So at the end, what we need to do is to return count plus mod, then everything's right. So that's the 2 things, right? The two things that did not do before, and I did it and it worked. And also we have a time limited. That's when I use big integer. Okay, big integer no concern whatsoever for mod. I did not mod at all during the computation. It's always just current plus something, and at the end I modded. But you know, it's not working. It's not working. But anyway, that was the solution, and it's not good, and it's very long, very convoluted. So someday I'll go back to this one and then figure out how this one works. So shall we do a palindrome? You want to do a palindrome, or you want to keep exploring new things? I might do palindrome, you know. Might do palindrome, and this one I need to do this so I don't see. I want to do palindrome. A nested. Let's see, what's the next problem? Maybe you can just keep moving on, or can do that. We have to go inside problems. Hard, medium. Locked. All right, let's do an easy one. Let's check if the number is fascinating. We give an integer that consists of exactly 3 digits. I call the number fascinating if, after the following modification, the resulting number contains all the digits from 1 to 9 exactly once, and does not contain any zeros. And it concatenate n with a number 2 times n, 3 times n. Return true if n is fascinating, or false otherwise. Okay, so what we want to do is find n. No, we're given an n. We do a double and do a triple and put them together, and see if they occur only once, every one. Is that required to be no duplication, or? Yeah, exactly once, and does not contain any zeros. So it has to be, the length has to be 9 with no zeros, and everything occurs only once. How would you do this in, what would be the fastest way to do? I'm trying to, okay, not fastest way. It's going to be fast no matter what. You just need to find a easiest way to do. Well, check the length is 9. Well, you can use a set. Or what? No, I don't think so. I think what we should do is, nah, that's not going to work. That is not going to work. Yes, that's the only way. I would think we can compare a string, right? We can compare a string, but you have to sort it. And you cannot sort a string. You have to turn a string into an array. You sort the array, and you turn an array into a string, and then you compare. That seemed to be excessive. So what I think, I mean, concatenating itself is turning into a string. So at the end, you do have a string. You have a string. I mean, we don't really have to do a string, do we? We just put them into, yeah, I think I'll do set. I'll do set and then check 0. That's how I would do. Let's do that. Let's do that, horse. Let's horse it. Horse. So we need a set. Character. Ugh. Alright, then what? Ugh. Then we put n in there, right? We say for ugh. Alright, look, grand. It look great.
I know, I just broke off.
Oh, it's okay. Leave it there. No, don't leave it there. Jimbo's gonna do something about it.
I'm sorry.
That's okay. I first of all, I have more ropes, and secondly, we always have a, what's that called? Floss. Once I get floss, it will never fall off.
Flamingo.
When they even do it? I didn't even notice. String n str is equal to, or what is that? String dot value. I still remember. Okay. Then we have to say for int I equals to 0, I smaller than nstr dot length plus scene dot add nstr dot char at I. So we'll do the same thing for all the other three. Just we don't do it, we'll just do that. So 2 times and 3 times. Return a scene dot contains 0 cannot contain 0 and scene dot size is equal to 9. That shall do. Oh, what? What? How did I get it wrong? That's bonkers. Wait, what's 783? Wait, what? Alright, I did not expect this one to be wrong, to be honest. Alright, let's see. N 783. Jimbo. Let me system dot. Oh, I don't have to. There's something called debug. I just debug it. Alright, 783. 1566. Oh, exactly once. Ugh. Oh, I have to go both. I realize. Oh my god. Well then you might as well. No. So we just do, can I do s plus equal to, right? I can do plus equal to. String dot value. I don't know, it's not doing well. Why you do this? Why you do this for? You can just put them together. You don't even need to do it this way. You can just put them together. And then put them together, right? Then we do... Can we do... I'm not sure. NSTR dot to char array. Is that possible? How do we initialize a hash set? Array.list, array.as list, that one can go. I'll just add it. It's fine. Oh, we just add it. So we do this. Sin.size equal to 9. Right? And NSTR dot length is equal to 9.
Color.
Oh, are you kidding me? Ay, ay, ay. I'm racking my head.
What was it?
Yeah, the temperature's racking my head.
Oh.
I mean, I'm definitely not concentrating on this because this is an easy problem. I got it wrong. That's right. I put them together and then we said this and this has to be 9 and this has to be 9. Yeah, I think this is right. Come on, please be right. It's too embarrassing. Yeah, this one should be right. What? Is there an easy solution? Because this one only 48%. I would check the people's review. What do you guys say? Very simple, very easy, using set. Yep. Does someone have a Java one? I need to learn how Java works. Wait. Where's the other problem? I think I accidentally deleted the other problem. That's not good. Shoot. Count integers. This is a JavaScript. Let's have a Java. Show me a Java one. C++. Lord. You think a cat picture will get me to upvote you? I don't think so. There's a lack of Java solution at the top. Alright, it's fine. I just call it. I want to call it a day. I'm not in the mood to do more. Alright, that will be it.